Hello everyone, welcome back to my channel. My name is M. Ganeshmani, USN 1VE 22EC056, pursuing my PE in ECE stream at Sri Venkateswara College of Engineering. So the course name for today's video is Microcontroller and the course code is BEC405A. So the topic for today's video is logical instructions, which comes under the instructions topic under module 2. So the contents that we'll be looking into this video in order to understand logical instruction is, first we'll be looking into the introduction about the definition what the logical instruction is about. Next, the types, that what are the instruction available. We'll be looking into the types of instructions. Then we'll be looking into the case study, means we'll be taking an example of a program and we'll be understanding how this logical instructions play an important role in writing a code. And at last, we'll be concluding our video by understanding what logical instruction is about, and we'll be recapping about the important points that we have listened in this video. So first, we'll be understanding about what logical instruction is about. So first we'll be understanding the definition, that is logical operations in 8051 perform bitwise operation between the accumulator and the data stored in a memory location, register or data given in a programmer. The result of the logical operation is stored in the accumulator itself. Types of logical instructions or operations that are AND operation, OR operation, NOT operation, XOR operation, rotate operation, and swap operation. So first we'll be looking into the AND operation. So AND operation stands for multiplication in Boolean logic that we know, but in coding how it is done we'll be understanding it now. So the definition states that the AND instruction compares the bit in the source and the destination operand and then stores the result in the accumulator after performing the AND operation. So in the coding, the AND operation compresses a bit and there are a source and a destination where the source is the given register and the destination is the accumulator, and after performing the AND operation the result is stored in the accumulator itself. The operands that are used is accumulator, registers, address, direct address, and indirect address also. So we'll be looking into an example, that is move a hashtag 55h, and we'll be performing the AND operation by writing ANL, which is the operating code or the operating operand we can say. So there we'll be writing ANL a comma hash 05fh. That means that ANDed with a and 05h, the accumulator contents and the 05h are ANDed together and the result is stored in the accumulator itself. So this is how AND operation works. So next we have OR operation. So the definition is the OR instruction compares the bit in the source and the destination operand and then stores the result in the accumulator after performing OR operation. So in this we can understand that OR instruction compares the bits in the source as well as destination. So after comparing, it will be storing its data in accumulator itself. It has the same operands that we see in AND instruction also, that are the accumulator, general purpose registers. Then comes address, then immediate address and indirect address. So example, we can understand that move a hash 55h, that means loading a content in accumulator that is the value of 55h, and then ORL a comma 0fh. So ORing the data between, or the comparing the data between accumulator and 0fh and storing the result in accumulator itself. So this is how OR operation works. So next will be NOT operation or complement operation. So NOT operation is also called as complement operation, where the complement instruction inverts all the bits stored in the accumulator. The operands are same, and we can see the above example that move a 0fh loads the data of 0fh in the accumulator, and CPL-A, which stands for complement of A, resulting which the the 4 bits are, or the 2 nibbles are replaced in that 8-bit data, where you can see that F goes to the higher order nibble and 0 comes to the lower order nibble. So this is how it is complemented. And it is also has a statement which is called as clear, where if we use the statement of clear, it is also clearing the whole data which is stored in the accumulator, and it is restored to 00h. So these are the operations of NOT or complement gate. So next we have XOR operation. So the definition states that these instruction compares the bit in the source and the destination operand, and then stores the result in the accumulator after performing the XOR operation. It is similar to some of the OR operation, but the XOR operation varies according to the instruction, that it has the same kind of content that we know in DSTV also, that XOR instruction actually performs the data, where it collects the data, compresses it, and takes it in the form of, like, the gate is drawn between A and B, and then it transforms into both product as well as sum. So there where it XOR plays a role. And then comes the operands which are used, which is same, that is accumulator, general purpose register, address, immediate address, and indirect address. The example that we can see here is move a 55h hash 55h, which means loading the immediate value of 55h in accumulator, and XRL is the coding word for XOR operation, and there we write in the form of in the destination accumulator, and in the source we have 0fh, that means XOR a with 0fh, and the result, which is 5ah, is stored in the XOR in the accumulator itself after performing the XRL function. So this is how it XOR operation takes place. Now the rotate option. It is of 4 types, where it rotates the value in the accumulator by considering the carry flag. There are 4 types, that are rotate right, rotate right with carry, rotate left with carry. When we ask this carry, after the 8 bits there is a carry flag attained, which is also known as the 9th bit. It is actually taken place in accumulator itself, so the operand is accumulator. One of the example that we'll be looking into is move A81h, where the data is loaded in accumulator, immediate data, that is 81h. Then rotate A, where the rotate RLA stands for rotate left A. So the rotate left resulting in the form of the 1 bit is shifted according to left side, and RLCA means the carry bit, the rotating left through the carry flag also. So this is how the rotate left takes place, and the rotate operation is done. At last, it is the swap operation. So swap operation means it exchanges the high and the low nibbles in the accumulator. So the operand is only the accumulator which plays in the role in swap operation. So one of the example is move A, which is equal to move A comma hash 3ch, and then by swapping passing the swapping instruction, that is swap A, the result is equal to C3h. We can see that both the nibbles have been exchanged. So this is what swap operation plays into the role. So at last we have an example program. So let us understand this, that is the case study. So now let us understand this example program. Let's write an example program that demonstrates some of these logical instruction. The program will perform the following tasks: initialize 2 registers with the value, perform AND, OR, and XOR operation, invert the bits of the register, set, clear, and test specific bits, rotate and shift bits, assume the hypothetical microcontroller with register R0, R1, and R2. So that was the question, and this is the answer to it. So first we can see the above two instructions would be initializing the registers, that is move R0 with the immediate address of 055H and then move R1 with 0A0H. So this is where the initialization of register has taken place, and we can see that what is the value of R0 as well as R1 is initialized, and then comes performing the AND operation. So where we can see that AND R2, R0, R1. So we have here performed the AND operation between R2, R0 and R1, where R2 is equal to R0 and R1, R2 is equal to 0B, that is 00000. So that is where we have come across this AND operation. Then comes the OR operation. It is the same, but what happens here is there has been the comparison between R0 and R1, and the resulting data is stored in R2. So the AND operation is done between R1 and R0. Similarly, the OR operation between R1 and R0, and the result is stored in R2. So as we can see that R0 ORed with R1 is equal to R2. So the data is 0B11111010. So this is what the OR operation is. Then comes XOR operation. In the same way, we can see that R2 stores the value of R0 XORed with R1, that is R2 is equals to 11111010, same as OR operation. And next comes invert bits, means which is the NOT operation or the complement operation. So where we can see that R0 data is inverted and stored into R2. So we can come across that whatever is the value of R0 is being inverted and stored into R2. Then comes set data, where the setting of value takes place in R0. So the data is given 3 and R0 is being set. So setting bit 3 of R0, that is R0 is equals to 010111101. So this is where it comes into 03, or we can say in the form of, it is written in the form of 50H. Next comes the clear data, where the data is totally cleared and we can obtain the value of R0. So that is how the clear instruction takes place. And then in the similar way, rotate left, rotate right, shifting of values bitwise has taken place, and we can see that all the tasks have been completed. So this is where logical instructions plays a huge role in attaining this, facing this problem, and we can understand how it is done. Whatever we have studied till now, that let it be the types of logical instruction. So even the example, we can see that logical instruction plays an important role for performing logical operations, such as we can compare a 2-bit data, or if we need to multiply it or divide it, we need to perform in the form of binary data, then we require logical instruction. So that is where logical instruction plays an important role in the microcontroller programming. So the reference have been taken by technobyte.org and Wikipedia, and the images have been used by Pinterest as well as Canva. These are the references that I have taken in this video. So thanks for watching this video. Please do like, share and subscribe to my channel. Hit the bell icon for latest notification. Share all your views in the comment section below. Stay tuned for more upcoming videos. Goodbye.